Alright guys, in this video we're going to talk about how to solve an equation for a variable. So for these problems, they want us to solve for y. And it could be x, it could be y, it could be c, it really doesn't matter. And you're going to treat it just like a normal equation. So we're solving this for y, keep track of where it is. There's only one y and it's on the left hand side. Now the problem is, we want this to be y equals something. I don't really care what that something is, but my goal is to have y over here. Now, a couple rules. You cannot have y on both sides of the equation. So if you have y equals 2x plus y, this is not solved for y because there's a y on the other side of the equation. Alright, so in our example, we got this 2x here. So what you're going to think of is ignore the x entirely. How would we make this 2 disappear so we can have just y all by itself? We would normally subtract 2 over. So it's 2x, so all we do is subtract over 2x. So 2x minus 2x is nothing. You got y equals, now it's 10 minus 2x, or negative 2x and a 10. These are not like terms. If this was 10x, then this answer would be 8x. But they're not like terms, so it's just 10 minus 2x, or negative 2x plus 10. It's not 2x minus 10 though. Either way you look at it, you have a negative 2x and a positive 10. So either one of these answers is fine. Most people will probably write the first answer, but as we get to starting to write the equation to lines, you might start going with this version. Doesn't really matter. So why don't you try the other two and then pause it and then come down to the next one. Alright, we're going to resume with example 4. So we have x's and y's on both sides. So just like before, and it's even in the same order here. We're going to get rid of this 12x. Now it's a negative 12x, so we're going to add 12x over. And we're left with 3y equals 12x plus 9. And the last one I did, I left it as 9 plus 12x, or the equivalent. Doesn't matter. So you can write it in either order. Now, last thing we have to do, these 12's go, is we have to get rid of this 3. It's not 3y equals, we want to know y equals. So it's 3 times y, so we divide both sides by 3. Now, you got two options. You can divide the whole right side by 3, or you can divide each part separately by 3. It really depends on the problem. Now, I like doing it this way because 3 goes into 12 and 9 nicely. This gives me 4x plus 3. If this was like a 7, I could write it 12 over 7 and 9 over 7, but it wouldn't do anything. The other option for this is to write it as 12x plus 9 over 3. The problem with that is, if you can reduce it, I expect you to reduce it. So this is the answer I expect. And again, these two can be in either order. Alright, why don't you try 5 and 6. Actually, let's do 6 together really quick, since let's get that over 4 business. So, y is not in the same position. It's not always going to be the same position. It's here too, though. We have to get rid of the 3x, so add the 3x over, because this is a minus 3x, so we want to get rid of a minus 3, so we add 3. So y over 4 equals 3x plus 7. And again, 7 plus 3x is the same thing. But it is not 10x. These are not like terms. Now, how do we get rid of over 4? So this really means y divided by 4. And you get rid of division by multiplying. We're going to multiply 4 on the left, and we're going to multiply 4 on the right. Now notice I put the parentheses. We have 4 times the quantity of 3x plus 7. Now, it doesn't matter which side it's on. You can put the 4 here, or the 4 here. But it has to be the whole thing. It's not just the 3x. So y equals, we distribute the 4 in, so 12x plus 28. And that's it. Alright, turn the page over if you haven't yet. I'm just going to highlight some of the trickier problems on here. So let's do example 2. I'm hoping example 1 is pretty easy. So we got y, and it's kind of nested in here. So we got two options. We could distribute the z in, or we could divide the z away. It's really up to you. And your answer might look a little different from your neighbor's answer if you do it one way or the other. So what I would suggest is not putting the z on the y. We want to get y all by itself, so we want to get rid of the z. Now z times, and it's a negative z times this. So how do you get rid of multiplication? You divide. So we're going to divide both sides by negative z. Now on the left, they're going to cancel, and we're left with x minus y equals s over z, over negative z, sorry, or a negative s over z. There's only one negative there, so it doesn't matter if it goes up top, bottom, or up front, but only one of them. Alright, so we got x minus y. We have to get rid of the x. Now this is a positive x, so we're going to subtract x over. Now, you got to be careful. A lot of people lose the negative on the y. It's a negative y equals a negative s over z minus x. So what we got? You can put a negative x there first and the s over z, but since they're just letters, the order doesn't matter too much. And technically, for order, it's alphabetical, but z is here and s is here, so it's kind of weird to tell. Are we done? Unfortunately, no. We've got a negative. We don't want this to be negative y equals, we want it to be y equals. So you got two options. You actually have three. And the easiest, I think, is multiplying both sides by negative 1. A lot of people think of it multiplying by negative. Well, negative isn't a thing. Negative 1 is a thing. So I can multiply both sides by negative 1. Negative 1 times a negative 1y is a positive 1y equals. Now, a negative times a negative is a positive, so s over z is positive now. And a negative times a negative is a positive x. One of the easy ways of thinking about this is you can flip all of your signs on both sides of the equation, always. You just have to make sure you get all of your signs. So that's my final answer. It's kind of ugly looking, but that is what it is. Alright, let's try example 3. That one looks really tricky. We got all sorts of stuff. We got all sorts of variables. So y is here. And when you're solving for a variable, whether it's numbers or letters in there, you really have to work outside in. So the r is the farthest away from the y. The h and the s are like attached to it. So we're going to subtract over r. So we got z minus r equals negative hy over s. Now, you could probably do this in like 3 full steps, but the easiest way is to realize you have a fraction in front of your variable. So to get rid of a fraction, you're going to multiply by the reciprocal, s over h. And there needs to be a negative in there somewhere. So we're multiplying both sides by a negative s over h. And depending on how picky you want to be, y equals all this. Everything else is going away. So I can write this as y equals negative s over h times the quantity of z minus r. And that would be a fine answer. I would accept this answer. If you want to distribute, then fine, but you don't need to. Negative sz over h plus sr over h. Now, this is a fine answer, this is a fine answer, but if you're going to distribute, make sure that you distribute correctly, especially watching the signs. Alright, let's do example 5 as well, and I'll leave you the other ones for yourself. Alright, y is on the bottom here. You get a fraction equals not a fraction. Or is it? So the trick to this, or at least the trick I see, is making x into a fraction. And anytime you have a fraction equal to a fraction, you can cross and multiply. And the big thing is, I want to get the y out of the bottom, more than anything else. So we got xy, this times this would be xy, equals 1 times s plus z, so that's just s plus z. Alright, so what's the last thing that's stuck with the y? It's x. So all I'm going to do is divide by x. Now, if you look back to one of the first examples I did, I put like s over x plus c over x. But look, x isn't going to go into either of those, so you might as well just leave it. So it would look like this also. S over x plus z over x. Doesn't matter which way you go about it, you can use it either way. One word of encouragement for this section. Most of these students in MedTech Algebra do a really good job at solving normal equations. Solving for x, 2's and 3's, this is not any different. So if you're good at solving the normal equation for x, and this looks weird, I'm sorry, but it's the exact same stuff, so don't get disheartened. Sorry, I lied. We're going to do one more of these problems down here at the bottom. Trying to just think about which one we want to do. Alright, well, let's do the first one, and maybe we'll do another one or two and see how it goes. So we want to write an equation and then solve for the variable specified. Solve for y. Okay, so we have to write this out. So negative 3 times multiplied by a number, x, so times x, plus 4 times the number y equals 10. So the way I just read this, just left to right, negative 3, there it is, times the number multiplied by a number. Number, what number? X. Plus, here's my plus, 4 times the number y, and that equals a 10. Okay. And now we just solve it for y. So we'll add the 3x over, add the 3x over, and we get 4y equal to, now it really depends, 3x plus 10 or 10 plus 3x. I started writing 10 plus 3x, and then felt like I want to change it, but it doesn't matter. Alright, divide both sides by 4. And so there's my answer. Y equals 10 plus 3x all over 4. So for a couple of these problems, it's going to be a little bit trickier to actually write out the equation. But once you have it, it's no different than any of the other ones. Alright, I will leave the rest of these for you. And have fun with the Fahrenheit and Celsius one. That's kind of cool. I think it's cool.